So, how do we do a stem and leaf plot? Well, let's look at example 1, the real world example on the top of page 116. It says the table lists the maximum running speeds of various animals. How can the data be displayed to show the distribution of the speeds? So here's what a stem and leaf plot does. It shows us where the data is clustered, okay? Shows us where the data is clustered, and it's just an easier way to read that. So we have all these animals, the elk, the cheetah, greyhound, wildebeest, quarter horse, zebra, giraffe, and the coyote. And we have their speeds that they can run. Now, this is going to sound familiar because with any graph, we're going to look at the range of the data. What is the smallest number that we see, the lowest running speed? What do you see, Hazen?
32.
You see a 32. Right? 32 is the lowest, okay? So we're going to set up our stem and leaf plot, okay? Stem and leaves. And the very first number is going to be the 32, okay? Now, the way that we set this up is that the vertical line between the stem and the leaves, it separates place value. So in this case, it's separating which places. Which place values are my stem and leaves separating? The tens and the ones. The stems are my tens, the leaves are my ones place. Now, with every stem and leaf plot, you have to have a key. 3 separated by 2 equals 32. That tells me that I'm separating the tens and the ones. Otherwise, maybe I'm separating the ones and the tens, or the hundreds and the tens and the ones, okay? So without the key, I don't know which place values I'm separating. So I have 3 separated by a 2. All right, so 3 to 2 equals 32. What's the next speed? 32 then? 39. Okay, I've got that 9 in there somewhere. All right, and then I just start filling it in. Now what's in the 40s? I have a speed of 40. 43. Now notice the stem is the number that all the leaves have in common. 40, 43, 45, 47. Okay? So the leaves all share one thing in common. The stem, whatever number that is. Okay? So that's how I break it down. All right, now in the 5s, I've got a speed of 50. A speed of 50 and a speed of 70. So this is how I would do my stem and leaf plot. Okay? Now I'm going to go ahead and pause the video so that I can answer any questions. Alright, so let's do another one. Now in this stem and leaf plot, okay, let's go ahead and look at page 117, or I'm sorry, page 118, number 7. You're welcome. This is one of your homework problems. Okay? All right, but I want to show you, all right, you're going to have to do number 6 on your own, and it's just like this one. I want to show you one that involves a decimal, okay? Now, this one's a little goofy because now I'm not separating the tens and the ones like in the last example. What am I separating? What places am I separating? Worsay? Okay, but what place values is that? I'm separating the ones and the tenths place, right? Look at number 7 on page 118. Okay? So now my stem is going to be the ones, and my leaf is going to be my tenths place. So what's the smallest number? I always look for the smallest number in the data set. On number 7, what is the smallest number that I see here? Justin? 0.8. So what number would belong in my stem if it's the ones place? Quentin? A 0. Very good. And what number would be my leaf? The 8, not the decimal. Okay, and that's one thing that I wanted to bring up. You never see a comma, you never see a decimal in your stem and leaf plot. That's what the key is for. The key will tell you that it separates the ones and the tenths. So there's no decimals in your stem and leaf plot. So 0.8, what's the next number? 1.1, what's the next number? 1.2, what's the next number? 1.5, then? Another 1.5. Okay, so then another 1.5, so I need to write that 5 twice. Now I go to the 2's, 2.4, 2.8. Okay? And I just fill in the rest of the stem and leaf plot. All right? So, but what am I missing here? Based on the first example, what am I missing? Hazen? I'm missing the key. I have to have the key. Without the key, if I'm just looking at the stem and leaf plot, that could be 8, 11, 12, 15, 15. I don't know what place values the stem and leaves are separating, okay? So the key is important. Now, I can choose any number in the stem and leaf plot for my key. It doesn't have to be the first number. I just have to show two numbers separated by each other and then what they would equal, 4.3. Okay, so 4 separated by 3 equals 4.3. I just randomly chose a number. You could choose a different number. It doesn't matter as long as you show 4 to 3 equals 4.3. All right, so the next one, you don't exactly have to write in your notes, but I want it in the video, so we're going to go ahead and cover it real quick. All right, and the next one, we're covering 3-digit numbers. So what do you do when you have a 3-digit number? All the other ones that we've been doing only have 2 digits, so it was easy to separate the place values. I just separated tens and ones or ones and tens. But what if you have a 3-digit number? Now, they all have to be close in value. It can't just be like random numbers like 130 and 640. They have to be close in value, otherwise the stem and leaf plot just doesn't work. Okay, but in this case, I would still break it down, my stems and my leaves, all right, and then I'm still separating the tens and the ones place. Notice that I have a lot of well, not a lot, but I have 2 numbers that are in the 130s, and I have 3 numbers that are in the 140s. So my leaves are still my ones places, but now my stem involves 2 digits. That's perfectly fine, because my leaves are still what each stem has in common. All right? It's still 142, 147, and 149. So the stem is still what basically the digits that they're sharing, the leaves are sharing. All right, now in example 2, now we're interpreting a stem and leaf plot. So we're on the page, top of page 117. Okay, we have point totals for a bicycle stunt competition. All right, and they give us the totals listed on page 117. I'm looking at the numbers that start with 89.4. Okay, now again, there's a decimal involved. This is kind of like that 3-digit example that we just did. Okay, so how do you think you're going to break down this stem and leaf plot? How do you think you would break it down? How do you think you would split it up? What would be the stem and what would be the leaf? What do you think? What do you think? Looking at the different numbers, looking at how they're displayed, what do you think? 2 people know? 3 people know? Justin?
It's like 70, 80, 90 or something close to that.
Okay, well there's no values in the 70s. All right, Hazen?
You would go, like, what's the lowest number?
The lowest number is 84.1. So how would you split it up?
On the stem, you would put 84, and then you would go 84, 87.
Okay, very good. All right, so I'm going to break it down, okay? In the stem, I'm going to have my tens and my ones. In my leaf, I'm going to have my tens place. Again, remember, the stem is whatever the leaves have in common. Okay, so my smallest number is 84.1. That's how I'm going to split it up. The hardest part about the stem and leaf plot is figuring out how to divide it. What is the stem and what is the leaf? Remember, it's important to see what digits are those leaves sharing. Okay, well in this case, there's 2 digits in the 84s, 84.1 and 84.3. Then what about the 85s? What values do you see in the 85s? No. Any scores? No. There's 1. 85.6. Now what about 86? What about 86? What would belong in my leaves on 86? This part's important. If you get anything from this example, you need to get this. What would you put in your leaves for 86? Hazen?
A 0 and then the 7.
Why a 0?
Because there's no decimal at the end.
Do you see the 86 whole number in the second column on the bottom, on the second row? Now, if you don't put a 0 in for the leaf, it's like that number doesn't exist. So you have to have a 0 in for the leaf, otherwise we're not counting that number. Does that make sense?
Yes.
Okay, so if I'm separating the ones in the tens place, but there's nothing in the tens place, I still have to put a 0 to hold the place. All right, so I have 86.0, 86.7. Now I go to 87. I only have one, 87.5. 88, 88.2, 88.9. Got a lot of 89s, got a lot of 90s, and a couple 91s. Okay, so we just filled in the rest of the stem and leaf plot is basically what we did. And notice with 90 and 91, I had to have those 0 placeholders as well because those are whole numbers in my data set. Okay, so don't forget those 0 placeholders, otherwise those numbers won't be counted. Okay, now what am I forgetting? What am I forgetting here? I'm forgetting the key. Okay, so do not forget the key. That's like your directions to your map. Okay, you're lost without it. 85 separated by 6 equals 85.6. That tells your reader, whoever's looking at your graph, what place values you're separating. Now, if I wanted to make a conclusion about this data, okay, so this is interpreting the line graph. Here's what you need to remember. Where is the data clustered? Where is the data clustered? That's what you're looking at when you're making a conclusion. So if I want to make a conclusion about this graph, I would say, because I'm looking at where the data is clustered, most skaters scored an 89 or above. Does that make sense? Because you see, it's all clustered, keyword, down here in the bottom part of the stem and leaf plot. So most, I would say, right on your paper, most of the skaters scored an 89 or above. And if you understand that, that's everything you need to know for 3.3.